last class, that was last 2 days, we started looking at string as one of the what we call reference data type that is not a primitive type. The primitive types are basically the 8 primitive types that we have mentioned and we've discussed intensively. But now we have seen that string is not a primitive, it's what we call a reference type. And we know what a string is: a sequence of characters and numbers, special characters, all enclosed in double quotes. So we have seen how to get the length of the string, get the character at a particular index using the char at, then you now specify the index. Just like going forward here, let me see. Okay, let me move back. Yes, something like this. If I ask you here, what is the character at? You remember, this is what you call index. 0, 1, 2, 3, 4, 5, 6, 7, up to this. So if I ask you, what is the character at index 8? What can you say? Character at index 8.
O.
Oh, great.
Sure, sir.
So yes, oh, thank you. So that is for character at a particular index. Now I can give you the character and ask you to give me the index. Now, if I ask you what is the index of O, what can you say?
It's 8.
It's
But it's 4 since
Yeah, the index of O is what? 804. 4.
it's 4.
You know, it's starting from left.
Yeah.
Yes, it's starting from left. So the one that is encountered is the one that will be returned. So the index of that will be 4. The index of O is 4. But if I say, what is the last index? Remember, we have last index. Last index of O is 8. Now, if I ask you, what is the length of this string? The hello world. What is the length?
11. 11.
Are you sure?
It's 12.
Okay,
Yes,
12.
it's 12.
Yeah.
It's 12.
It's 12.
Yeah, it's 12 because it's indexing from 0. So if you can't, when you are counting characters, you will not count from 0. Only that the position of the first letter is 0. So when you are counting, it's always 1 more than the last index. Is that right?
Yes, sir.
Yes. So the length of this is 12, and that is why here we said length xtr.length minus 1. And length minus 1, which is 12 minus 1, will give us 11. So 11 is the last index of this. So the last index of any string is the same as the length of that string minus 1. Length of that string minus 1. Please take notes. Length of it minus 1. So we have seen the length, we have seen the character at, this is how we said it's represented. This is for the index of. If you want to get index of, then we now specify the character. So given the character will give us the index. And don't forget that the index is just trying to tell us the index value of a character in the string. So, and this is saying the index of, like that of the previous example that we have seen, we have many O's. But if we want to get the index of the last O, then we can now say starting from the next one, not this one. So here now we can specify the index, we can specify the character, and then the begin index. From where will it start checking? If it encounters the letter, then it will return the position of that character. So given this, like we have this as a string, and we say phone number dot index of, what is the index of dash here? If I say index of dash, what is the index from this, if this is a string?
3.
3.
3. So the index of this is 3. So take note, this, that means this, but this index 1 is going to return what value? IDX1 will going to return what value? What value is going to be stored here? Is 3, as you mentioned.
It's 3.
Yeah, right? Okay. Now, if you move on, system.out.println index of first dash, which is 3, no issue. Now, phone number dot index of this, then index of this plus 1. So that means from the next, what is index 1 plus 1? Remember, what is index 1? We said is 3, right?
3.
It's 3 from
plus
here.
1.
So plus 1 is 4. So that means it's going to start from where? It's going to start from here and check the next one. So it's going to go until it sees the character dash, then it stops. You see that? So this is it. So we'll now print out the second dash and the position of the second dash. So we know the position of the first dash and the position of the second dash. So if you find the index of the first letter, then you can use that to increment and then check again if there is that character, return its own index. So that will give you a way to even process everything from beginning to the end, searching for a particular character. Is that okay? Because you first search, this can be like 1 million of this, which is not easy, and you don't know the point at which the dash occurred. So what you need, search for the first dash, you return the index. Then when you are checking next, you not start from beginning, but rather you start from the next index after the occurrence of the dash, which is here now. So you now start searching. Is it a dash? No. Is it a dash? No. Is it a dash? No. Is it a dash? Then yes. Then return it. So when you are checking next, already since you know the index of this, when you are checking, you check against the next one. Is it a dash? Is it a dash? This until you get to the length of the string. So just make sure that you don't exceed the length and you don't check after the length. And in fact, the length minus 1, because the index of the character at a length does not exist. It's always length minus 1. So this is the use of the char at. If we have this, we want to get the char at 0, that will give us S. Char at 3 will give us A, because this is 0, 1, 2, 3. So will give us A, like that. And then moving on to substring. How can we get part of string from a string? Extract string from a string. If you remember the example I gave you last 2 days, having an email address. This is an email address. We want to extract username and domain name separate. So if you want to extract the username, what's separate between the username and the domain name is the @ character, isn't it? It's the @ character that separates the two. So why can't you find the index of the @? If you find the index of the @, then we now extract from beginning till the index of that @ character. So that will give us what? The username. Then if we want to extract the domain name, we start from the index of @ character plus 1, which is from G, till the end. So that will give us the domain name. And regardless of the length and regardless of the email, as long as you take this, will work for all. But if you just count to say you want to extract from here to here, what if I give you a shorter length of the domain, the username? Somebody might just be like Ismail and at gmail.com, which probably Ismail is not as long as Engineer Abu Sadiq at gmail.com. So in such kind of situation, if you are to count, that means you are doing it specifically for that username. So what if the length is not known? So you have to use the @ character to determine the username. So we get the index of @, and the index of @ will now be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from 10. So we now come here. This is where we printed the length of the string entirely. Then the character at, that is the index of the @ character, which is already extracted from here. And again, we now get the substring. Substring starting from 0 till the index of the @ character, which is here now. Remember, when you say substring, you are extracting. So all you need to specify is the beginning and end. Beginning of where you want to extract till the end of where you want to stop. So this is the beginning, start index, and this is the last index. So by always -1 of this, when you are getting substring, the last one here is excluded. The last one is excluded, because if this one is included, it's going to return even with the @ character, while we just want to get 1 before the @ character. We want to stop there, 1 before the @ character. So it's going to be from 0 to the index of the @. Then move on to username. That is already, because we have already extracted the username from substring here from 0 to the index of the @. Then we print out the username. Next is to extract the domain name. The domain name will start from the index of the @ character +1, so that it will start from G till the end. So this is where we have @+1 till the end. So there's supposed to be comma the end. So if you don't specify the second parameter, it assumes that the first one is specified, but the last one will be the end of the string. So it will stop at the end if you just pass one parameter. Remember here, we have 2 parameters here. 2 parameters here, while we have just 1 parameter here. So if you have 1 parameter, that is the beginning, the end till the end of the string. Okay, so then here we have, and then we print the domain name. So that way. So if I change this to either short or long, it does not matter. All the same, it will work the same thing. So it will give us the domain name Alex, while the username is this. So we say regardless of the length, it's still going to work, no issue. So whether 3 letters, 4 letters, 5 letters, 10 letters, it does not matter. So this is the idea of, and that is one good thing about programming, make it general, not specific. So that is substring. So this is the one I've just explained, using one parameter that returns substring from beginning index, that is from the index that you specify here, to the end of the string. While this is the beginning, this is the end, but excluding the end value. So means not including the end index. So if you say, let's say from 0 to 10, then it's going to extract from 0 to 5. Let me give you an example here. Let me say here, I have string G, this. So analysis dot substring dot substring, let's say 3. If I print this G, what value will it going to print? If I have this, can you tell me the letters that will be printed if I have just G.substring3?
Good.
Okay. Are you sure? Remember, we said if we have just one parameter, that is the beginning, the end to the end till the end of the string. So if you have just one parameter passed to the string method, so that is the beginning. So the beginning of where we are to extract is what now? Is index 3.
D.
Since the second one is not specified, then it will be till the end. Is that clear now?
Okay, sir.
Yes. So if that is the case, from what is the first letter that will be extracted after this?
Is D.
Remember, this is index 0, 1, 2, 3. So it's going to start from where? From index 3, isn't it? Which is here till the end. So in that case, the output of this will give us this. This is the output of that. When we say 3, it's going to start counting from index 3. 0, 1, 2, 3. So that means it's going to start from here till the end. But if I have this, let's say 0, 3 to 5, what will be printed? Remember that if you have two parameters, the last one is always excluded. The last one always excluded, meaning it will not include the last value. So it's going to stop one before the last value. So where is the starting point? Which letter
We
is the
have
first
D
letter?
and space.
We have D and space. That's
Yes.
all?
Yes, sir.
Okay, great. Because if you look at this, the starting point is 3, which is here now. 3, 4, because we said 5 will not be included. Always 1 before the last one. If we have the last one, it's always 1 before the last one. So the last one is not included. So it's going to stop at 4, which is 3, 4. So that is D and space. Now, if I send this now, let's say 5, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say to 10. Let's say 9. 5 to 9. What is the length of this totally? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. Isn't it? We have 9 characters. So if I say from 5 to 9, where is 5 to 9? Tell me all the inclusive values. Inclusive from left to right. What are the inclusive values? If I have 5,9, is 5 included?
Yes, 5 is included.
5
So
is
what
included. Oh,
so
sir,
what
there
about
is no
9?
9.
9 is not included.
9 is not included, so it's going to stop at
8.
8. Okay, so let's go. This is 0, 1, 2, 3, 4, 5. So it's going to start from O, from this, isn't it? 5, 6,
Yes, sir.
7, 8.
Sir, there are 8 characters there.
Oh, 8 characters, are you sure? Let me count.
You start from
1.
0. Oh, no.
Okay. So you get it now, right? When you're counting, will you count to say 0, 1, 2? When you're counting, if you're counting, you can start from 1. But when you're checking at the index position of every character, that is when you start from 0. Okay?
Okay, sir.
Yes. So take note, the position is different from the length. Length is to count the number of characters, which basically you start with a natural counting 1, 2, 3, 4, 5, 6 till the end. But when you are looking at the position, especially when you are extracting, so in that case, you extract based on the position of that, because that is how it's indexed internally in the computer system. The first character is given a position 0. The next one is given a position 1. Next one given a position 2, 3, like that, so that we can extract the string, we can process it, we can do a lot of things by knowing the position of every character. But if you don't know the position, there's no way you can manipulate it. Yes, if you don't know the position, just like now, you don't know where to pick something. If I ask you to go and pick it, where will you go and pick it? But if you know the position, you know how it is represented internally. So we have the idea that, oh, this is how it's internally represented in the computer. So we know by the time we extract, we know how to process it because we know how it is internally represented. But if that is not known, there's no way you can process any string. Yes. So when you are counting, you count from 1, 2, 3, 4, 5, 6. But when you are checking the index, you start from 0. So if that is the case, we stop at 8 here. And therefore, this is 5, 6, 7, 8. So it's going to give us 1 with question mark, exclamation mark, like this. Okay. So what if I say G dot length? Is it okay? 5 to G dot length. What is G dot length? G dot length means the length in the character G, in the string G. What is the length of it?
9.
It's 8.
9. 9. No, the length is 9. But since now we are extracting the substring, so it's going to stop 1 before this number, ideally. So that is from 5 to 8 inclusive. Then it will get this for us. So this is why I said, if you know that the end is till the end, you can just use this dot length. Because right from the beginning, you might not know what is the length of the string, but you know where to start. The end is not known. So you can just use G dot length. Is it clear or confusion?
It's clear, sir. Thank you, sir.
Okay. Okay. So basically, like this one now, we say from 0 to 5. 0 to 5, which is from here now. 0, 1, 2, 3, 4, 5. Then it will now, remember that if you say 5, it's going to stop where?
You stop on
If you have
4.
0 to 5, it's 0 to 4. Thank you. 0 to 4. So 0, 1, 2, 3, 4. Then it will bring hello. Then 7 to 11. 7 to 11, 0, 1, 2, 3, 4, 5, 6, 7, which is here now. 7 till 11. So 7, 8, 9, 10. So it's going to stop at 10 because the 11, the last one, always will not be included. Once you have 2, this comma this, the last one is always not included. So it's going to be from 7 to 10. So 7 to 10 will be 1. Then 7, when you have 7, it means till the end. When you specify just one parameter, it means that is the beginning and the end till the end. So that will give us what? World, because this is index 7. 7, 8, 9, 10, 11, 12. Then it will go till the end. That's just the thing. So now there is another special method called replace. This method replaces all occurrences of matching characters in a string. So it's going to check if there is a matching character then it's going to replace. A replacement is given the old car replaced with the new car. That is, we search through and replace with something. Suppose now we have a string here. It's called str. And we say using string replace character. So from this, see, this is the variable that is storing this. So we now make use of this str dot. Remember, this is the object now, dot replace, because we are now replacing on str. If you just say replace, from where are you replacing? What are you replacing? Oh, we know we are replacing r with r, but from where? So we need to specify from this object that is holding the string value here. So str dot replace r, that means wherever there is small r, replace it with capital R. So it will change this r now to, and change this r to. So system.r print line this, then we now see using the string replace to this. So you see wherever there is r will be changed to capital R. Is this clear? I know this is not difficult. Just find a replace if you like. So all occurrences of a lower case r are replaced with capital R. But you know it's case sensitive. It does not mean when you change, you put capital R here, you put capital R and there is no capital R and expect it to be with small r. So there is replace first. Here now is replacing everything. It's replacing everything. But what if we are only interested in replacing first? Yes. So replacing first, we just use the replace first, then string pattern, what is it going to match, and then the replace character or replace string. But this is not just, even this, if you look at it, is a string notes a character. So like here now, I can look at this and say using string replace to replace character. So I can, let's say, for instance, search this character and replace it with something. Or let me say this is good. I will now change the good to bad. So I will just replace good with bad. That's all. So must not be a single character. An example is this, string replace with replace first. So that means wherever there is RE, we replace it with what? This capital RE. So where do we first encounter RE? We encounter RE here. Therefore, this is the one that will be replaced. And this, why is there is another RE here? This will not be replaced because of the first replace first. So exercise for you, check this exercise 1, part 1, that says create a new project and add the shopping cart.java and namemaker.java files to the project, where a question will be asked. So use the index of method to get the index of the space character. So please, if you really want to understand this, you need to do a lot of practice. Check the exercises, try them. So now declaring and creating a string. Yes, we started discussing on how to process string, but string can be created in 2 ways. You can instantiate strings in 2 ways, that is it. One way is this, making the data type here, then the string reference, then followed by the string literal value. String literal value. But because we said this is an object, that's why we call this string reference. It's an object. If it is an object, it can be created with a new operator here. So either you write this like this or you write this like, but in a short form, we'll normally write it like this. We don't have to bother ourselves writing like this. But other classes that we have created or from other classes that we're going to use or we have been using, it's not allowed to shorten it like this. But this is a special kind for string that allows this kind of declaration. So you can either use this or use this. If you look at it, everything the same, only that's in the place of this value, we just use a new string and then we close it in this double quote. which is basically how we create an object of a class using the new operator. So just to let you know that string also is an object. That's why we call it string reference. So we say strings are immutable, meaning that once they are created, their values cannot be changed. Even if you change the value, it does not mean another one will be created. So it does not mean you are changing the value. It is another string that will be created. So meaning, understand that if I have something like this, and I say here, sorry, and I come here and say G equals to bad one. So here I declare G to store good one, fine. And here we have the same G that is assigned bad one. So if I print G, what value will be printed if I'm going to print G?
Bad one.
Bad one, because the value of G has been changed. So it's going to print bad one. Now the issue is, does that mean it's actually changing? If we have changed, we have this as a content, and we now come here and assign this to G, does that mean the value in the G has been changed even in that memory location? So internally, you may look at it here as, okay, yes, the value is overwriting. So meaning you will have something that you are storing, but you now get something replaced with it. So as far as the compiler is concerned, it doesn't alter the one that is already created. It's going to keep this and then create another memory with a new value G. So when you change the value of whatever variable, that is, when you change the value of this G, it does not mean this value will change. No, this will still remain in the computer memory, only that another memory will be created to store this new value of G. So this is one of the things that it says, so what happened with this G? This is what we call garbage collection, because it's no longer needed, but it's a garbage collection. So the value of G is not, or a string value cannot be changed. That's why they call it immutable, meaning you cannot just say, okay, you change this one now, and it means the value of this G has been changed. It is a new one that will be created. Just like, for instance, I say, okay, you make a mistake. You are supposed to write in the page, and you make a mistake, and I ask you to correct it, and then submit it. So you might decide to bring a new plain sheet, then write the correction and give it to me. What happened with that old one? That is what you call garbage collection. But in the situation whereby you can alter that one that you have started writing on without bringing any other separate sheet, then that means it's mutable. It's mutable. You can change. But in the situation whereby whenever you write and make mistake, whatever you write in that sheet of paper, you cannot alter anything. You cannot change it. You just have to leave it as it is. If at all, you can now find another sheet and then write what you want to write and submit to me. So what will happen with the old one? I discard the old one, or you discard the old one and submit a new one. Yes, but if changes is allowed, then you don't need to bring a new plain sheet. You can just alter that old sheet that you have started, and then make the correction, then submit. So we said in Java, once string is created, it's not possible to go there and change anything. That one will be discarded, and again, a new plain sheet will be created where that new value will be stored. So this is what I think, by giving you this scenario with a plain sheet, you understand what we mean by immutable. So when this G is created, and which is, remember when we say G created, it means it's a computer memory, a space in a computer where a value is stored, and the value is called good one, is stored there. So whenever there is a mistake or we want to replace something inside, So it does not mean that one that has already been created is going to be altered. No, that will still left. And then a new one will be created with a new correction. So what will happen with the old one is what we call garbage collection. So yes, Java handles the issue of garbage collection using a finalized method, which I don't want to talk about the issue of garbage collection, but just to let you know that anything that is no longer needed but already captured, occupies space in a computer memory is called garbage collection. So as I keep changing this now, if I'm going to change this now to this, I say, let's say extremely. Extremely good. And again, change the value of G. So how many values now, or how many memory spaces have we created so far? We have created how many that will have distinct values?
3.
3. Yes, 3. But in the case of, let's say we have integer a equals to 6, and then a equals to 7, a equals to 9. Now, as far as this is an integer, and it doesn't have garbage collection, and if it's not said to be immutable, meaning the value can change. So if the value can change, it means when you have a memory called A and you store an integer value, when you come to assign a different value, it is not that a new memory space will be created with a new value. No, it is that same old one that will now be overwritten by the new one. So in the case of primitive types, they do change the value in that memory. But in the case of string, it doesn't overwrite the one that already created. It discards it, and then a new one will be created with a new value. So that is what we mean by immutable here. So a string is immutable. That is, after a string object is created, its value can't be changed. Can't be changed. Understand that can't be changed. It does not mean when we come here, we say, oh, we have changed the value of G. That means it has changed. No. Why we say can't be changed? This is created. So when you assign a different value, then a new memory space with a new value will be created. So that's what we mean by can't be changed. So the old one will no longer going to be changed. The new one will change. That is a new one that you have assigned a new memory will be created with a new value. As you keep doing that, any number, the same thing is going to happen. So like, because strings are immutable, Java can process them very efficiently because they don't change. And if they change, by the time you have a value, then if the value has changed, then the whole thing will change. So consider the following: string 1 and string 2, all of them hello 1, hello, hello. We expect this, like this string 1 to be hello and string 2 to be hello. So string are immutable, but this is what happens. String 1 is having a hello. String 2 is having a hello. So the Java runtime system knows that the two strings are identical and allocate the same memory location for the two objects. So that is why even if they have the same value, but it is not that when you have a new one will be created. So this is one of the things that we said is immutable. Next is concatenation. Yes, we have seen concatenation operator using a plus sign, but again, you can use Java concat method to concatenate two strings together. That is to join two strings together, or to combine two or more strings together. That is multiple string using concat. So meaning if I have like, let's say here now I have G1 and I come here and I say this G2, then somewhere here I said G1 dot concat G2. What it does is just to concat, that is to combine, and it will say good 1, bad 1. This is what is going to. Concat means join, just join. But if there is a space, if there is no space, of course, it will be something like this. Yes. If there is no space, it will be something like this. If you want a space, you can preserve the space immediately after. So if I have now system.out.println, then I will say this is, I will cut this. This is what I want it to print, so I will print it here. Then we now see the concatenated G1 and G2. So you see, it's a good one, bad one. Look at it. So this is the same as writing G1 plus G2. When you have system.out.println, you can use G1 plus G2. The plus, since they are all string, so you can decide not to use a concat method. You can say G1 plus G2. They all mean the same thing. If you check, they will all give the same. Okay, where do I have arrow? Okay, system. Again. Okay, sorry. G1. So you see, it gives the same result. So whether plus or you use concat, they all mean the same thing here because it's a string. It's a string. Well, the only thing you cannot use concat when you have an integer, because integer are not reference type. And why we call this G1 and G2 are reference type, because we are making reference to them. But if this is an integer, we cannot use this and make reference to it. That's why we call it reference type. Okay, so this is the concat, and we have seen the use of concat example here. If you want to concat two strings together, we use a plus sign. This is 1. Using a plus sign, this will add this and this. And then using the concat method, you can, that is another example is when you have string and number. I think I've discussed this with you. When you have a string and number, you can use a plus sign, then the result will be a concatenation. Yes, will be a concatenation. When you have total plus 17 plus 17, as far as this is concerned, it's going to do concatenation. It's not going to say put 17 plus 17 and then concatenate with this. It's starting from left to right. Therefore, it's going to concatenate with this and then concatenate with this. That's why the result will be like this. Total 17, 17. But if you want to have 17, 17, 17 plus 17, then you need to bracket them. When you bracket them, then it means bracket first. So it will now add this and this and see 34. Then concatenate with this string. Then that will give us total 34. So these are common mistakes. You should be very careful when you have string and we have integer to add, and then we have string. So make sure that if we mean addition, we should bracket them. Otherwise, since it's from left to right, it will take precedence and it will do a concatenation. So the same thing here, we have 17 plus 17. It does not mean it's going to say 17 plus 17. No, it's going to concatenate them because one of them is string. So it's going to join them together and say 17, 17. But if I remove this double quote, then this is an integer already. So if this is an integer, of course, I cannot assign integer to a string because integer plus integer will give us integer and cannot be assigned to a string. But because this is a string, this is an integer, then it will do a concatenation and the result will be a string, which is fine. It's going to assign to this string value. And then when you print, you will see 17, 17. So using the concat method, this is my string, which is this hello, and then concat world. So you now say, this will now concatenate my string, which is hello, and world. So it will be hello world. So this is the work of the concat. This is another one, concat. When you concat, you now use a plus sign to use a question exclamation mark to concatenate together, because this is going to return a string from this concatenation, and then concatenate with question mark, sorry, exclamation mark. So exercise for you, this is the completion of the, okay, sorry, that is compare method. So Java string allow us to compare two strings together to check if two strings are the same. So you can compare two string objects by using the compare two methods. And this is checking based on the characters, that is lexicographical order of strings. So the lexicographical order here is checking letter by letter and the ordering of the letter. That is what is checking. So the lexicographic comparisons are similar to the ordering found in a dictionary. Just the way we have a dictionary, they are already sorted alphabetically. So when you are looking for a word, you know where to go and check, okay, I'm looking for absent. So I will just go to A, B, S, then go there at least more precisely. I know this is the point where I should get it. So that is the way it's checking to see if there is a match, just the way we have it in the dictionary. So the strings are compared character by character until their order is determined and until they prove to be identical. So if there is one letter that is not the same, then as far as Java is concerned, the two strings are not equal. So how do we compare them? We use this syntax, s1.compare to s2, means that s1 is a string and you want to compare with s2 as a string. Yes. So just like here now, I have G1 and G2. Say I will now write this compare to G2. So will G1, remember this is going to return true or false, it's a Boolean. Will G1 equals to G2? When we compare G1 and G2, remember we said it's going to compare letter by letter, lexicographic comparison. So is G the same as B? No. So right from here, we know that they are not the same. They are not the same. So what it does is it's going to check the ASCII value of G and the ASCII value of B. If they are the same, then it moves to the next character. Again, O and A. If they are the same, they move on to the next character. If they are the same, move on to the next character until where it says that the character is not the same. So the compare to method will return 0 if both characters are the same. That is, each character in that corresponding order happen to be the same. And return positive if one is greater than if the G1 is greater than G2 in ASCII value, or if G2 is greater than G1 in ASCII value, to return negative. That is to say less than. So compare to method doesn't just return equal, but it returns either positive or negative. So what we are saying here is it returns an integer value that indicates the ordering of the two strings, the ordering. Please pay attention. By the time you start Cox 301, you need this compare to method, especially when you want to sort something in some lexicographical order. You have to use this compare to method, unless if you want to use a natural ordering. So you can use this to customize the order in which you want something to appear. So the return value by compare to method, the integer returned by the compare to methods can be interpreted as follows. Return 0 when the strings calling the method is lexicographically first. is logographically first. So meaning in ordering, remember, in ordering, it becomes first, then the second one. Let's see now, remember we said the integer value returned by the compare method can be interpreted as this, less than 0. When the string calling the method is logographically first. So which one is calling the method here now between G1 and G2? It's G1 that is calling the method compared to. Now, if this G is logographically first, then it's going to return what? Negative. So let's check here, G and B. In the real order, which one's supposed to be first?
B.
Yes, which one's supposed to be first between G and B?
B.
Yeah, as usual, we know when we are talking about the ordering, we are talking about the alphabetical order. B will come first. So that means this will return positive. But if the first one, which is G1, is the one that is calling the method compared to method, happen to be first, then it's going to be negative. So let's say, for instance, G2 now that is now calling the compare to method against G1. So we are now saying, is this compared, this is going to B will be compared with G. And between B and G, which one comes first? B. So therefore, it's going to return negative. It's going to return negative because B comes first before G. So meaning when you take a higher number and subtract from, when you take a lower number and subtract from the higher number, what is going to give you? Negative. So this is why now it says when it's less than 0. When it's less than 0, that is G2 is comparing with G1, and that is based on the graphical order. And G2 comes first in that order, then it's going to return negative. It's going to return negative. Now, the other way around, positive. But if they are the same, let's say, for instance, B and B, the same, then B and B the same. As far as this is concerned, B and B is going to return what? 0, because whatever the ASCII value of this, the ASCII value of this will be that value minus value because it's the same. It's going to be 0. Next, we'll now compare O and A, but because we are making G2 to make call to the method compared to against G1. So between A and O, which one comes first? Is it A that comes first before O?
A.
Yeah, so
A
this will
comes
now
first.
be, yes, this will now be negative again because A minus whatever the value of A, the ASCII value of O is greater than that of A. So A minus the smaller value minus larger value will give us what? Negative. We are not interested in the difference. As long as it returns negative, we know it's just typically negative. So that is the comparison. And again, when the two strings are logographically equivalent, then it returns what? 0. The other way around, when the parameter passed to the method is logographically first, that is the one that is in the parameter is the one that comes first, then it's going to be positive. So it means you don't have to disturb your brain thinking of something. What matters is this one that is calling the method? Therefore, it's going to return negative. If this one, G1, that is calling the compare to method against G2, happen to be the first in the logographical order, then it's going to return negative. Yes, like I said, this is done internally by the computer system. This is done internally by the computer system. It is not going to be done by you. So you don't have to worry, but just to tell you, this is how it is done. This is how it is. Because if I ask you now, what is the ASCII value of BOD, we don't know. I and you, we don't know. So, but what we are saying, this is how the computer used to do the comparison. But internally, since it knows what is the ASCII value, then within microsecond, it gets that and that's all. Okay, so good one. Let me just come here and say compare to. And compare to method, we don't need to import it because it's in java.lang package, which is in the objects class. It's in the object class, so no need of any. So you see, what can you see here? It returns what? 5, for which is what? Positive. For which is positive. So the positive is saying if this G2, the one in the parameter, in the lexicographical order come first. So that means this G2 come first, then what? Then good one. Because this is G2. Bad one come first, then good one. But if I change this now to bad one, everything the same, then this is exactly equal, then it's going to return 0. Because lexicographically they are the same. When you match the letters, everything the same. Everything. But if I remove this, then they are no longer the same. So this would return a different value, which is 1. Now, if I change this now to, let's say I change this to be, I take back the exclamation mark and change the first one. This return negative. See? So if one of these is higher, then the other one will be lower. So if you reverse it, of course, the reverse is the case. So this is now negative. That means when you look at it from the negative perspective, it means the one that we have here comes first than the G2. So remember that everything here is the same as this. Yes, but this has nothing, but this has something. Therefore, definitely, you know, this is less than this. G1 is less than G2. And that's why we have a negative. So this is the comparison that checks based on the lexicographical order. So now let's look at this. We have computer.compare_to comparison. So look at this. Here we have computer as a string. Take note, this is a string that we are comparing against this. Now, returns an integer greater than 0 because comparison parameter is lexicographically fast. Lexicographically fast. Now, if you do the matching, C with C, O with O, M with O, P with P, but then U, this is U, this is what? A. This is A. So, and this is T, this is some. So you see, if you look at the right from here to here now, the next is just to compare this and this. Looking at the ASCII value, you can find the ASCII value and check which one comes first. And even, in fact, the letters A, B, C, D, E, F, G, from A to Z, these are letters. And if you check based on the letters, the arrangement of the letters, one is greater than the other, which, if you can remember, I've shown you how to get the ASCII value in this case. Let's say, for instance, system.out.println Then if you want to bring the ASCII value, you just say int, like say for instance, and then say A. Then this will print you the ASCII value of A. By wrapping, this is a character A. So if you wrap it in an integer, then it gives you the ASCII value of that A, which is 97. And if you write a capital letter A, it will give you 65. So if I have A as this, 97, what about B? B will be what? So let's see B. So you see B is higher than what? 98. That means the order of the alphabet A, B, C, D, E, F, G, like that. That is the ordering. And if we have A, we know that A is less than B, B is less than C, C is less than D, D is less than E, like that, in terms of ASCII value. So this is why when I make comparison of the letters, we'll just check which one is at the higher, which one is at the lower. So that will give us an idea of what should be the difference. Okay, so now next one, let's say this is B. Let's change this to C. You'll see that is the value, ASCII value of this would be greater than 98. So we have 99. That's sequential order. Likewise, for a capital letters, which is less than the small letters now. So you see, this is 65. Now, if I take capital B, it should be greater than 65, which is 66. So you see that ordering. So therefore, if I have this to compare from this CMP, everything the same, but U and A are different. So if you check the ASCII value of U, we know A is 97, U is what? U is 117. So which clearly shows that A is less than the second one. It's less than the second one. So that is why in that case it's going to return negative for A. And then you keep checking this against this. You discover that, but not just to say because by checking one letter, no, you have to check for everything. And then at last, you will now be able to get whether positive or negative. So the same for this curve and car. If you check the CAB and car, the CA the same. B here and A and R, thank you. So let's use this as an example. Return an integer 0 because curve string calling the method is logographically fast. This curve that is calling the method is logographically fast. Why do we say fast? CA, then next is what? B will come first, then followed by what? R. This is logographically fast. And if you check the ASCII value B and R, we know B is 98. B is 98. Yes. Then R is what? It's 114. So if you take the difference, then it's going to be what? That 98 minus 114 will give us negative. That means this comes first. This comes first, and that is why we have less than 0. If you take the difference, 98 minus 114, it gave us negative. So that means this comes first. B comes first, then what? R. But if you interchange them, take this car compared to this, then it's going to be positive. Okay, sorry, this is the same. But if you change this car to this, then it's going to be positive, which means this one that is changing will be negative because this is the one that is calling. And it's not logographically fast. R is not logographically fast. Therefore, it's going to return positive. Because if you subtract 114 minus 98, it's going to be positive in that case. So that means it's not the one that is being called, but the one in the argument that comes first. Then for this car, they are the same. That's graphically equivalent. Therefore, it's going to be the same. So this is more on the compare to method. Okay. So summary on that. I don't know. So do we still move ahead or we stop here?
Let's stop here,
Yes.
sir.
Okay. So question? Any question from you guys? Is this one clear, very clear, or?
It's clear, sir.
It's
Okay. So thank you. I think we'll stop here.
All right, thank you, sir.
thank you, sir.
Thank you.